So, welcome back, everyone. Today, we have an exciting episode because we're going to talk about a fairly new thing that people have been hearing around artificial intelligence. So, it's called reinforcement learning. So, everybody's been hearing about all these different types of learning, and this one is fairly new. Luca's going to tell us all about it. Luca?
Yeah, actually, it is. Let's say that it is now a very popular approach because
Hmm.
there is a lot of promises around reinforcement learning. However, I must say that it's not a new technique. It has been invented actually quite a while ago, because the paradigm is a very how can I say? It's very straightforward actually.
Hmm.
Let's say it's the carrot and stick paradigm. Like you're trying to teach the machine to perform a specific task or a job, and in exchange of a good performance, the machine or the algorithm gets either a reward or penalty. Okay, so
Hmm.
the algorithm, our reinforcement learning algorithm, is essentially a machine learning paradigm where the machine learning model, has to make a sequence of decisions. So I would like to stress this sequential nature of the functioning of the algorithm, because it's very important and it has a lot of implications even in the training of the algorithm. So the second very interesting thing is that the algorithm goal is to learn in a very uncertain and potentially complex conditions. So this is what makes reinforcement learning very attractive, because we have a lot
Hmm.
of scenarios where this is the case.
Okay, so the thing that differentiates it is that it's sequential nature and the fact that it's
Mhm.
really good to use in really complex and uncertain environments. Yes?
Yes, and maybe this is a good moment to understand a little bit better on how it works. So how this
Hmm.
methodology is put in place. So first of all, you have an agent. Okay, so the
Hmm.
algorithm obviously has to take a sequential number of decisions and or actions, and these actions are projected towards an environment where the agent is interacting. And then there is an interpreter that is judging the performance of the agent. And the interpreter also has the task of giving rewards or penalties to the agent actions. So maybe I can give you an example so that all this makes more sense and it is a little bit clearer.
Hmm.
So for instance, let's take an autonomous vehicle. In this case, the agent would be the pilot, the autopilot algorithm that has to take an action, either steering the wheel clockwise or counterclockwise. So let's make it simple. Let's forget about the acceleration for the moment or the gears. Let's imagine that the only two possible actions are steering the wheel in one direction or another. Obviously, the environment is the environment where the car is moving. In this case, let's simplify to the max. Let's think that this environment is the road, and
Hmm.
the interpreter has to reward the agent, so the algorithm, in reward or penalize it in two scenarios. Scenario number one, it keeps the car on the road, or the car goes off the road.
Hmm.
So if the agent or the algorithm manages to keep the car on the road, it gets a reward, otherwise it gets a penalty. And obviously the agent will learn over time to keep the car on the road by perceiving the environment where they are acting. For instance, an agent that is equipped with cameras would understand that when there are specific signs, the road is ending, or maybe there is a curve. So some specific actions need to be taken. So there's a lot of going on here, but I hope that this clarifies a little bit more the functioning, or the main entities that needs to be trained into a reinforcement learning architecture. What do you think, Michelle?
Okay, so just to clarify, the interpreter is actually a human being, right?
Well, yeah, that's a very good point. The interpreter could be a human being, because in the case of the autonomous vehicle now,
Hmm.
these autonomous vehicles are trained with the human being in on the car that takes the
Hmm.
control when agent makes a mistake. So yes, it could be a human being in this use case.
Okay, that's really interesting because you, in your example for the use case of the car, you made the point that as you're training the algorithm, right? It's
Mhm.
also a matter of the car is taking note of what is happening as the training is happening. So it could be that at the beginning you have an actual interpreter, which is the human, right? That takes over when the agent makes a mistake.
Yeah.
But then it could be the case that if enough time, if enough training has passed to a certain degree, you can take the interpreter out, right? Because then the learning that has gathered from like the first period can then be used instead of having a person there. Am
Yeah,
I correct?
exactly. Yeah,
Okay.
you're correct, and this gives you an idea of how flexible and how powerful this, reinforcement learning architecture could be. Because essentially, you could, by changing the definition of the interpreter and then
Hmm.
of the environment, you can really, make this adapted to your use case. For instance, I could say maybe the interpreter is a sensor that determines whether or not the surface um, of the road is there, or if the tires are hitting the edges of a road. Okay,
Hmm.
so there are many ways in which we can define this interpreter, and certainly this is just one example, one of the examples. There are many more. Now, obviously, we're not gonna go through the all the potential use cases, because we're again out of time. But I hope that we gave you guys an intuition of how this works. And in the video, there is going to be, in the video description, there are also some references that you can consult if you want to know more about reinforcement learning.
All right, perfect. Thank you, Luca. And for those of you, tune in next time for the challenges around reinforcement learning.
Thank you. Bye bye.